Now what is relation? To understand the definition of relation, let's take one example. Let set A is A, B, C. Set B is P, Q, R. Set A is the set of children and B is the set of fathers. Now Cartesian product of A and B will be A comma P, A comma Q, A comma R. B comma P, B comma Q, B comma R. C comma P, C comma Q, C comma R. Now, relation is represented by capital R. Relation is given A comma P, B comma Q, C comma R. It means relation is given A is the child of P, B is the child of Q, C is the child of R. Or we can say P is the father of A, Q is the father of B, and R is the father of C. Now, we have these three elements in relation. All these three elements are also in Cartesian product of A and B. B comma Q is here, C comma R is here. It means we can say relation is always the subset of Cartesian product of these two sets. So, relation is always the subset of A cross B. Now come to the definition. Let A and B are two non-empty sets. Yes, here we have two non-empty sets. Then any subset R, it means we are talking about this set. Any subset R of A cross B is called relation from set A to set B. Relation is from A to B. Relation is from A to B. It means first element is from set A and second element is from set B. So relation is from A to B. And in relation we have always elements which are subset of A cross B. So any subset R of A cross B is called relation from set A to set B. So thus R is the relation from A to B if and only if R is the subset of A cross B. It means proper subset or simple subset of A cross B. It means all elements of A cross B can be the member of this relation R. Now we can represent relation in three forms. Number one is roster form. Second is set builder form. And third one is by an arrow diagram. Okay, first we will discuss about roster form. Let's take one example. If A is 1, 2, 3 and set B is 1, 2, 3, 4, 5, 6. And relation is from A to B. And what is the relation? Is square of. Now, is square of. It means first element will be of set A and second element will be of set B. Now, relation is square of. It means if we have 1, square of 1 is 1. It means we can write pair 1 comma 1. Now, 2 is the square of root 2. So here we don't have 2. 3 square of again root 3, and we don't have root 3 in any set. Now 4 is the square of 2. So 4 is the square of 2. Now 5 is the square of again root 5. We don't have root 5. 6 is the square of root 6. So in this relation we have only two elements, 1 comma 1. Now 1 is the square of 1. 4 is the square of 2. So here we have two elements in this relation. Now this is the roster form. Here in this roster form we write elements separately. It means we are writing an ordered pairs in the form of ordered pair. Only we have two ordered pair in this relation, 1 comma 1 and 4 comma 2. And if I am writing this relation as R is from A to B is defined as R because relation is in the form of x comma y. It means an ordered pair where x belongs to set A, y belongs to B, and what is the relation? X is the square of y. And if we write in the wording form, in the statement form, then this is set builder form. And if I am representing this is set A, this is set B. 1, 2, 3, 4, 5, 6. Here we have 1, 2, 3, 4, 5, 6, 7, 8 up to 16. Now relation between, we have relation between 1 and 1, and we have relation between 4 and 2. So this is the representation of the relation by an arrow diagram. So in this way we can represent relation in roster form, set builder form, and by arrow diagram. Now set A is set B is, and relation is given now what is the domain, range and codomain, and relation is from set A to set B. Now relation is from set A to set B. Now what is domain, codomain and range of this relation? Now these first components, or we can say first element of this relation, are called domain of this relation. So domain of this relation is 1, 2, 3, 7. And these second elements of set B, these are related to set B, and these second elements of this relation are called range of this relation, 2, 3, 6. Now what is codomain? If we are talking about relation is from A to B, then set B is called codomain. If we are talking about relation is from set A to set B, then set B is called codomain. And we can say range is always the subset of codomain. So first element of relations will be considered as domain. Second element of this relation will be considered as range. And if relation is from A to B, then the second set will be considered as codomain. And range is always the subset of codomain.